Newton's second. Most of the time you will see this as F is equal to ma. But this is, it's hard to remember this way. It's easier to understand this way. Acceleration is equal to force over mass. Look at it like this. RJ,
Yeah.
if force is a value that you would assign to the engine in your car, the engine in your car has a certain force to it, right? But your car also has a certain mass to it, right? And what you like about your car is its ability to accelerate quickly. So if you put a bigger engine in your car, arrow going up, what's going to happen to your acceleration? It's going to go up too, right? Makes a lot of sense. But if you don't change the engine in your car, but you have 10 of your friends pile in the car, what do you think is going to happen to your acceleration?
It's gonna go down.
It's going to go down, right?
Yep, you can go slower.
They better pay
It's
for
real
gas.
easy to think about Newton's law this way, as a ratio between the force and the mass.
Horatio.
As a ratio between force and mass.
Who's Horatio?
As a
Horatio
ratio.
is a character
Well,
in Horatio is a character in Blackjack.
Here's another way. A good visualization. We can talk about cars and things like that, and you guys all understand. But here's a good visual.
You should type.
So I tried to balance these balloons, right? So this is almost balanced, and that one's almost balanced, right? Right. So the force pulling down is equal to the force going up, so that it's balanced forces. Now if I change the mass on one of these a little bit, it's going to go up, right? Please go up. Go up. I don't have to take off another piece of cardboard. All right.
Just like on the other one, it was balanced.
All right. So I want them to go up. All right. Now I'm going to take more mass off of this balloon. So the balloon with the more mass or less mass is going to accelerate faster. The one with the less mass is going to accelerate faster. Now that's a good visual on Newton's second law. The same force was applied. They had both the same lifting force,
yeah.
and then I took mass away from one, and so it accelerated. Okay. So this is a force gauge, right? So if I apply a force to this hook, then that moves the needle. Now it's got a little cool feature that there's a little red dial, there's a little black dial right here that will move with the red one and show me what the maximum amount is, all right? So we're actually going to use that feature right now. So I'm going to apply a force to move this chair, right? It shouldn't take much force to move this chair. But when you're talking about friction, there's static friction. Static means not moving. Static means standing still. Static means standing still. Did you get that part? Static means standing still. So the standing still friction is different than the moving friction. Okay? So there's some standing still friction. I mean, I am applying a force right here. I am pulling on this a little bit. I don't know if it's moving the needle yet. Moving just barely. But then it starts to move. All right, so maybe I need another gauge. Let's see. I got all kinds of gauges. Here's one that might be better. So this one is just, it's for lighter, for less forces. All right, so I'm going to hook it. Right. So I'm applying a force, I'm applying a force, I'm applying a force, I'm applying a force, and then it begins to move, right? So it took about 12 newtons in order to pull and make this chair move. It takes about 12 newtons, actually less than that. It might vary just depending on where it's at on the floor. Right? So it takes a certain amount of force to get it moving. And that certain amount of force to get it moving is a static force. Now, the question is what happens when there's more weight on it? So Mara, come here and sit in the chair. Come here and sit in the chair. So make a prediction in your head. Is it going to take more force to move, pick your feet up so I don't want the friction of your feet. We're just talking about the friction of the legs on the chair, right? So I'm gonna pull, whoa, I already pegged this meter. That's not saying anything about your weight, honey. Okay, maybe it is saying something about your weight.
I don't feel comfortable doing this anymore.
On spots.
The chair broke. Oh my gosh.
All right, now I'm
That's
moving.
just-
Wow, okay, it took
No.
50 newtons. It took 50 newtons to pull the chair, it was 50 newtons of static friction in order to get, I had to overcome 50 newtons of static friction in order to get the chair to move.